Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of inequalities on a number line. This is standard 7.10b in the great state of Texas, and we are using item number 27 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a basic inequality here. We need to find which number line best represents this. So first off, what we need to do here is we need to isolate this variable. So I've got a negative 4x plus 29 greater than 19. So how do we isolate this variable? Well, what we do is we do reverse PEMDAS. All right, so when we're trying to simplify an expression, we go from the top down. But when we're trying to isolate a variable, we go from the bottom up. Right? So we're looking at addition or subtraction. I want to get this x by itself. And so I've got this plus 29 right there. So I'm going to use my properties of operations to eliminate that 29 from that side. Right? So I need to find the inverse. So if I'm going to add 29 to this negative 4x, in order to remove it from that side, I need to do the inverse or subtract 29. Now the properties of operations tell me that I can do this on one side of the inequality as long as I do it on the other side of the inequality. So that's going to keep it balanced, right? So I'm going to get negative 4x is greater than, I got 19 minus 29, right? So that's like negative 29 plus 19, so that's going to give me a negative 10. We might need something like a number line to kind of help us on this one. Right, so we've got 19, right, and I need to do minus 29. So I'm going to do a minus 19 jump right there, and that's going to leave me at another minus 10 to get me to negative 10. So that's how I visualize that right there. Two different jumps. And so I've got negative 4x is greater than negative 10. So I've done my addition and subtraction. Now I need to go to my multiplication and division because my x is being multiplied by negative 4, so I need to use the inverse operation, right, next, and that's going to be divided by negative 4, but same thing, properties of operations. If I divide by negative 4 on one side, I need to divide by negative 4 on the other side to keep it as a balanced inequality. So those two are going to cancel each other out. That's going to leave 1. Negative 4 divided by negative 4 is 1. And we don't write the 1, it's just x. Now, here's where it's going to get tricky. First, let's see what negative 4 divided by, or negative 4 divided into negative 10 is. We know that the two negatives are going to make a positive, so really it's just 4 divided by 10, right? So let's just simplify it, right? Divided by 2, because it's a really simple fraction. That's going to be 5 halves. Okay, so 2.5, 2.5. But here's the tricky rule. Whenever you multiply in an inequality, multiply or divide by a negative, which we did. We just multiplied or divided by this negative 4, right? We could have multiplied by negative 1/4 if we wanted to. That would have done the same thing. You flip the inequality. So now it's going to be less than 2.5. So whenever you multiply or divide by a negative to kind of isolate that variable, you flip the inequality. So x is less than or equal to 2.5. So I'm looking at my 2.5 right here. I'm seeing this less than. C is looking good. Now, how do we verify it? Well, let's just pick a number, right? That is going to be, let's just pick 0, right? That's going to be easy. Let's plug it back into the original. Negative 4, 0, plus 29 is greater than 19, right? We pick 0 because that's an easy one. That's just going to make that 0 out. So is 29 greater than 19? Yeah, it's a true statement. We could try it for any of these. We could do 1 if we wanted to. So negative 4 times 1 plus 29 is greater than 19. So that's negative 4 plus 29. That's 25 is greater than 19. Yeah, it works. So we can test these out to make sure they are going to work. So our answer here is going to be C.